In this video, we're going to be discussing survey design, also statistical bias and variability. In both of these sections, the Dana Center really only addresses these things in terms of a surface type of look, where we're looking at different ways a survey can be done, different types of surveys that can be done, and just trying to analyze and see what's different from one to the next. Also with variability and statistical bias, it's just an introductory type of atmosphere where we're trying to identify different types of statistical bias and what is variability. So here when we look at survey design, first we take a look at pilot surveys. Pilot surveys or pilot studies that was introduced earlier in the statistics unit. In this case here, we're looking for surveys that have leading questions, questions that are basically geared to make you answer one specific way. Question ambiguity, questions where the people taking the survey really have no idea what the question is asking. Maybe it's worded a little bit weird, or maybe it's worded improperly for the general populace to be able to answer the question truthfully without any bias. Also, too many people selecting the other option or the no opinion option. These are things that you need to watch out for, and a pilot survey is a good way to do a small scale survey to see if your questions are basically good questions for whichever population you're trying to analyze. And then we look at surveys that are designed with open questions and closed questions, and we analyze the pros and cons of what a survey with open questions versus closed questions would yield. A lot of the discussion for open questions talks about it takes more time to analyze the results of those surveys, so it costs more money, it costs more resources, whereas closed questions, true, false, yes or no, 4 answer choices, those type of questions are quickly analyzed and can be done in a short period of time, and so the money, the resources isn't near as extensive for closed question surveys as it is for open question surveys. Statistical bias. When we're introduced to statistical bias, we need to make sure we understand what statistical bias is or how it is created. These are several of the words or phrases that produce statistical bias. It is not everything, but it is several or most of them that the Dana Center provides us. Response bias, non-response bias, observer effect, wording of questions, and the placebo effect. We've already discussed placebo effect. When a group taking the placebo reports improvement just because they're in the study, they feel like they actually got something with effective ingredients when really they're inactive. Wording of questions we just talked about in survey design. Leading questions, question ambiguity, or questions that have other and no opinion that are answered a lot because maybe the answer choices weren't significant enough or sufficient enough for the population. Observer effect. Observer effect, the primary way the observer effect is identified is, especially with your students, you have that discussion, okay guys, whenever y'all are in my class, y'all act one way, but what happens when that principal walks in? For the most part, the students straighten up, they start looking like they're better students than what they actually are, or they feel like in their own mind the principal is wanting to perceive something different, so they act differently. So that's the observer effect. Non-response bias. We have the example of people wanting to get the opinions of the public about this new skate park that's created. Well, there's not going to be a lot of people call in to talk about the skate park because they have no opinion on it. They don't really care about it, so they're not going to respond. Also, response bias here is when some people, essentially the best way I like to look at it is when people lie because they think that's what the person doing the survey wants to hear. We have an example. It's kind of a weird example in the text, but it talks about how a young lady just goes to a store, she buys a bathing suit, and this older gentleman is doing a survey asking what they just purchased. And instead of saying what she purchased, it was a bikini or a swimsuit or whatever the wording in the question says, the young lady says she bought a sweater. Well, she didn't really buy a sweater, she bought a bathing suit. And so her response bias essentially was not telling the truth about what she actually purchased. Now that's going to be difficult to be able to actually analyze, but without searching the bag. However, it is a type of response bias where they don't tell the truth. Also, non-response bias, there's a lot of times at the end of a phone call for like AT&T, the actual company wants you to take a survey at the end of the phone call to see how their customer service helped you. Well, whenever you hang that phone up before that survey begins, that's considered non-response bias. You are not responding to their survey questions. Variability deals with the range of a data set. If we have a small range, we have low variability. Large range, we have high variability. In this case, we're looking at outliers that affect our variability because the difference between the lowest value versus the highest value in a data set gives us our range. Well, if our outlier is very, very small, it's going to tell us our range is much larger, or if our outlier is very big, our range is much larger than the majority of our data set. So the outliers here affect the range. However, whenever you're looking at the general idea of the data set, you don't necessarily take into account the outliers whenever you're trying to talk about the statistical bias based on the sample data set. So we're going to see that here in a second. In variability, the data center really only wants you to be able to identify high versus low variability. When we look at statistical bias and variability, when we analyze the graphical displays, this is what the data center essentially shows us. We have the true mean weight, or the population average, is given to us by some arrow or asterisk at the bottom of the graph. And then we have the range of data that's demonstrated simply by a histogram or a dot plot with no real meaning to the frequency of whatever data. It's just given to us as a generalistic type of display. So in this case here, if you just compare these two, this graph here has high variability, this graph has low variability. And then the true mean, or the average of the population here, is given to us here. This is basically centered inside of the range of data. So this has low statistical bias. And this one here is moved over to the left or to the right of the graph. It's to one extreme or the other. So this has high statistical bias. And this is how statistical bias and variability are intertwined in this data center, being able to identify variability and the type of statistical bias that is represented graphically. And that is survey design, statistical bias, and variability.